There you go. Hi, how are you people? Hi, welcome, welcome, welcome internet. Hi, how are you? I hope everybody's there connected. I will take this out and I will go to our document. So today we have the second class of the Introduction to Security, defining computers, scanning, and basic network analysis. So welcome everybody. We are still not with Andre here. Trust me, he exists, but he's at home sick, so we wish you well, Ondro. Hi, hi, hi. He's in Matrix with the rest of the team, so I think we are ready to start. This is the beautiful animation, not animation, drawing did by Fermin Valeros, and we have issues with our document. I'm not sure if you knew this, that Google Docs have limit in the amount of people that can be in the document. This is the first time we saw that. It's a new limit for us. After several hundred people, they just don't like it anymore. So yes, yeah, thank you very much. If anyone has issues with the document, just tell us. We are searching for alternatives to this, okay? So class number 2, the one where we are like Trinity and use Nmap. If you don't know who Trinity is, please leave the class right now. I don't like you. So yeah, I know some people don't know who Trinity is. Just go watch the movies. The first one or the second one. Well, not the last one. I don't like that. No, the last one. It doesn't matter. Okay, I don't want to talk about the last one. So we have credits, a new credit. We have now the CTU video recording people. Thank you very much. People in the background for all you are doing for us. There is a huge amount of stuff going on behind the scenes, and they're responsible. And also, we add audio files and sticker credits for Veronica, so thank you very much. So you have an idea of the complexity of the class behind the scenes. So you have the links, like everybody, every day. We are changing those. The recording, like last class, is going to be probably in 2 days. We are trying to speed it up, but it's very hard. So we are doing our best, and C2 is doing their best. Maybe we have the recording on Friday, maybe Saturday morning, okay, for all the people on the internet. So we are going to be using Wireshark today. So right away, if you don't have Wireshark in your computers right now, go install it. In something like an hour and a half, we are going to be using it, so you have time for solving issues and errors, okay? We have actually surprise Pioneer Prize. If you remember last class, we said we are not going to give Pioneer Prize in the first assignment. If you don't remember when I'm talking about internet, every week, or roughly every week, the people sitting here and taking the class as CTU students, they play an assignment CTF during the weekend or whenever, and the first one to solve it, actually they got some prize. And this year we have 3 surprise prizes. We are going to give to the third place, sorry for that, a PyGlow. A PyGlow is a small hardware hat that you put to the Raspberry Pi, and you have a lot of LEDs that you can program and play with. The second place is going to be an electronic badge that we got in a conference, actually from a company there that you can see. I will zoom in. The Not So Secure and ClearNet Cybersecurity. If you are listening, thank you very much. They gave us as a gift in some conference some years ago. And we have one, and this is for you. You can program that one, so it's a nice gift. And the first prize is a Raspberry Pi Pico. If you don't know, it's a small computer that you can also play and program and do whatever you want. Yeah, who won? So the third place goes to, that's a drum, to Tomasz Vesele 27. Congratulations, Tomashi. I'm not sure where you are. Are you here, Tomasz? No? Oh, we need to have a policy of what happens if you're not here to pick up the prizes. Yeah, but you know, so they do it. So is it you? We need an ID. No, I'm joking. Just okay. Thank you very much. Oh, what happened here? And the second place, there you go. Bravo. The second place goes to Pavel, something is on my computer. Sushitsky, Pavel, are you here? Bravo, Pavel. Bravo, bravo, bravo. Well done. I like that you didn't know there are going to be prizes, but there were, so this is well earned. Bravo. And if you turn it on, you have lights and lights. Super nice. And the first prize goes to Luboslav Motoshitsky. Are you here? No, he's coming. I don't know what about this. Okay, well done, Luboslav. Well done. Congratulations. And internet, I'm sorry, we cannot do this online because shipping things all over the world is a little bit tricky unless you have some solution to this. So thank you very much, people, for participating. This class, also we have the class assignment at the end of the day, open at 9 p.m. So if you want to play, it's going to be open, okay? So let's continue. We have results from the survey of the last class. Remember, at the end of the class, every class, we are asking you how was the class, and then we try to adapt. So regarding the tempo, most of you were okay with the tempo. Some of you got lost, some of you got bored, so I would say that it was kind of okay. The counting of how well could you follow what the teacher explained. Remember, the scale was from 0 to 10, so this is 10, 9, 8, 7, 4, and there is one 3. So most of the people were 10s and 9s and 8s, so far, so good. We will actually slow down a little bit, but that's it. Count how well could you replicate what the teacher showed in device. Again, 10s and 9s and 8s, so most of you could replicate. And the last one is, how did you like the support material? And most of you like it, so that's it regarding the feedback. Anyone can give us feedback online and here in situ. So just go to the feedback form and fill it for us, okay? So, parish notices, some local things that we need to tell you. The first one is thank you to all the online community on the internet that in Matrix is helping others. Many of you are going there and helping other people and telling them what to do in the middle of the night while we are sleeping. So thank you very much for that. It's very nice to see that everyone is helping others. We are gonna be doing small reminder of netiquette. So please, if you are chatting in Matrix, remember that this is online space, but you should conduct like in real life. Think that there is a person behind who is chatting to you, so they have a life, and they have things to do. So present your best side online, please, when you are chatting and when you're answering and when you're asking. Please first read and then ask. Many, many questions are repeated all over the place, and people is answering the same again and again. So please first search and read and then ask. Respect the time and the bandwidth of others. If somebody's answered to you, don't ask 20 times the same thing, right? They're helping. Be clear and precise in your question, please. If you have an error, give information about the error. Operating system, version, screenshots, the error itself. Don't go just and say it doesn't work, okay? It's kind of bad. And ask in the appropriate channels. We have people asking all over the place, and that's actually very confusing. So let's try to make this chat matrix a little bit better for everybody. So goal of the class, we want to learn how to find computers and services during the reconnaissance phase and how to detect this in the network, okay? So we are gonna go deep and fast. So PCAP, or it didn't happen. PCAP is a format for capturing packets. That means if you don't show me the evidence, it didn't happen. And this is one of the maxims of cybersecurity in networking, okay? Show me that happened with the PCAP, so I have the evidence to show. So before this, I forgot one parish notice that remember that we have people here, right, that are here for you to help. So if you have any issue, problem, you can ask them. Mar is here, Muri is here, Martin is here, and Lucas is here, okay? They are here for you. Just say, hey, help me in something, okay? Okay? So, ready to start? So, to start today, because we are going to be scanning and the rest, we need to store all this traffic in a packets format that we can see later. So you want to have a recording of your network traffic so you know who scanned you and who you scan and what happened. So the first thing in the class is to actually start capturing traffic in your network, okay? So please connect to your Docker, everybody online, Strato Cyber Lab, or in here. So this is my Strato Cyber Lab that I'm gonna make more bigger, and this is gonna be my BSI connection. So let's try to connect there. And the first thing we're going to be doing is finding which is the interface you are using to capture packets. And this is going to be done with the command IP. Remember, we did this before. And we are going to ask the command IP to show all the addresses. And we have here some interface loopback. The interface called ETH0, and I have an Ethernet 2 because I'm special. You should have the 0, okay, everybody? On the internet, the same. When you go to your Stratolab, you can do IPA, and you will have here all the information about your interfaces. And you should see here the Ethernet 0 something, okay? If you have a different one, just remember which one you have. Now that you have the interface, let's gonna try to see if we can actually get packets from that interface. And for that, we are going to be using the command that is called tcpdump. That is the default standard for capturing packets in the network. And we are going to say, hey, tcpdump -n, which means do not resolve DNS. That means if you see an IP address, do not try to get through DNS the name of the IP. Does anybody know why we are asking this to tcpdump? Why we are saying, hey, tcpdump, every time you see an IP address, don't try to get the reverse DNS name of this IP? Too much DNS query, that's good. So Lucas, right, is saying, hey, if you have 20,000 IPs, you're going to be doing 20,000 DNS requests. That's a lot. True story. What else? Very well. Your other people around you will see you asking, and actually that's probably not what you want. And there is a security one. There is a one that is regarding security itself. And it's because if you are gonna see, for example, malware traffic, or if you're gonna see somebody attacking you, you're gonna take that IP address that belongs to the attacker, and you're gonna try to get the name. And the DNS server probably is being managed by the attacker. So you're gonna connect to the attacker computer and ask the name of their computer. And this is the best way to give out that you are checking them and you know about them. And probably this is not what you want. So if you do that, the attacker will know, yeah, somebody is checking what I'm doing or my traffic, I have been detected. So by default, you try not to resolve DNS, okay? Then we are going to capture the whole payload, that's the S0, and the interface with -i, okay? So if you do that, you can do it in Stellato Cyberlab, or you can do it in your Dockers. You should see that, okay? Those are packets in the network going and coming from your interface. And this is actually not so good, because if you pay attention, you will see that each packet is going to say, hey, this IP, port 22 is talking to this IP in port 49,000 something. And this is you connected with SSH to your own Docker. So what you're looking at here is the traffic of your computer. And that's bad. We don't want that, okay? So first order of business is going to be to delete this traffic from your traffic capture. And for that, this is what I'm saying here, for that, we want to know exactly which is the IP address you are using to connect there. The easiest way is just looking at the traffic and say, yeah, this one is my IP, because it's the IP address that is connecting to my Docker 172.20.02, okay? That's the easy one. You can copy the IP address from there, bye-bye. However, we can automate this a little bit. And for that, you can use a variable that it's created by SSH that is called SSH connection. And when you do echo that variable, so $, it's for variables in your bash, you will see the content, and the content of this variable is exactly your own SSH connection. So this is exactly from SSH for you to have the information. And you can see here the first column or the first value is your IP, okay? So if you want to actually take out this packet from the capture, you can just say, hey, tcpdump -n -0 -e, and then you can filter. Filter in this case is going to be host, not some IP address. Host, exclamation mark, means not that IP address. And you just replace this IP address with the IP address you know, okay? So you can try that, and if it works, you should see no traffic. If you want to automate this a little bit, you can execute tcpdump directly and then use the magic of the bash substitution that is taking everything inside the $ parentheses, executing that, echo SSH connection, pipe, cat, use as delimiter the space, takes the first column, that's the meaning of this, execute this, and then take this value, which is the IP address, and use it as a host filter, okay? A little bit more advanced, but it's gonna automate the extraction of the IP. So if you run this, you should see no packets. That means you successfully take out your packets from the capture, okay? Everybody? Questions? Internet questions? Everybody clear why we are doing this? Why are you here? Why we are here? That's a good one, right? Actually. Okay, oh yeah, we have some packets there. So, alternatively, you can do a little bit more fancy things. So this is a little bit more advanced, but you can actually use the command SS, which is a beautiful command, and you should know it. SS, also coming from socket statistics, is a program that allows you to find which ports are open in your computer, which connections are there, everything. And you can use this command to actually get all the information from your computer regarding connections in the network. So I'm only going to execute the SS. So look at this, SS. And then it's, oh yeah, in your computer you have 3 listening ports and 2 established connections and all the information, okay? So this is very helpful to know who connected to your Docker. So if you do that, then you can grep, if you remember grep, filters specific expressions in lines, and then you are going to grab everything that says SSHD, everything that says from establish, then you're going to take the first line, that's the head, 1 line, and then you're going to be using a programming language called awk. If you don't know awk, I suggest you try to learn. It's a beautiful, very fast language in the command line, and we are going to print the 5th column. After printing the 5th column, we are going to separate the lines using the columns, and then taking the first one of the column. So let me execute all of this, and at the end, you have your IP address. Because it was taken from the SSH grep, so let me do the SSH grep, and then you search for establish, only the establish are these 2, then you took the first line, remember the head, right? And then we cut this one to extract this column exactly, okay? A little bit more advanced. If you are lost a little bit, it's fine. Just giving you the alternative to do more specific executions in your bash. At the end of the day, you should have a tcpdump that is not printing anything that's related to your IP, okay? If you are lost, you can go back to this command. This command should work for you and for everybody, and having everything on you. Yes? Good question. When I say your IP, I mean the IP of the computer you are using to SSH into your Docker, even your Cyberlab, okay? That's your IP. In this case, is the IP in the Cyberlab is the IP of your computer, because I am connecting to the Cyberlab that is running in my computer. In the case of the Dockers of the university, that's whatever IP you are using from the world, your home, or whatever. Okay? Everybody? Yes? No? In the middle? Yes. Perfect. Let's continue then. Now that we have this, let's gonna store packets in the network, okay? Store packets, we are gonna be doing in a format called PCAP. PCAP is a very old format file, and in that file, you have registers for each packet that you are storing, the standard for sharing information about packets. You can actually go and read the RFC, the request for comment document that is telling everything about the standard. Technically speaking, now we have PCAP NG, the next generation, which is much better, but we just, for historical reasons, stayed to PCAP, okay? Now, to do this, I'm gonna introduce Tmax, a type of virtual multiple terminal sessions manager. Anyone here uses Tmax or Screen? There you go, some people, internet. So Tmax allows you to have multiple terminals in one session. So you log in once. So imagine here, I'm logging in and I have only one session, okay? But I want to execute many things. And some things are going to be in the background. Some things are going to capture my terminal. I cannot keep typing. So for this, what you're going to be is tmax. To create a new session, you just write tmax new and the name with -t. So I'm going to create here a new tmax terminal called capture. When you press enter, see, you are kind of in the same place, looks like, but this is a virtual terminal now. Now we have two terminals, one on top of the other. So for example, I'm going to do here ls, so you can actually see that this is a specific one. And then to get out, you should do Control-B-D. Control-B-D. And see, I get out, and now I'm in the first terminal. So here, I'm going to write first. This is first. And if you want to connect back to the terminal that is running now in the background, you do tmax A. That means attach. And see, I'm back in the other one. OK, everybody? Tmax allows you to manage many terminals simultaneously. Very useful, very useful. You get remote control in some computer, and then you need to run 20 things. Tmax can help you in that one, OK? So now that you are in your specific tmax called capture, let's run a tcpdump program that is going to take all the packets and store them in the network, OK? And that is the command that we are going to be doing. So I will execute this, and then I'm going to tell you what it's doing, OK? Run it, please, and be sure. Tmax, new capture, right? And there you go. So what did we just execute? There are many things that we did before, like all the SS and host not my IP. That's the same as before. The new things are -v, that means verbose, -w means write in a file, and the file is going to have this format. It's going to be in TMP, it's going to call capture, and then it's going to replace this with a year, this with a month, the date, the hour, the minute, the second, .PCAP, okay? And we are going to be doing -L, which means do not buffer the lines, and then we are going to be rotating the files every 86,400 seconds, which is exactly 1 day. So that means go create a PCAP, and tomorrow just create a new one, and a new one, a new one, a new one. So you have 1 PCAP per day, okay? And only do this for 7 iterations. So we are going to store only 7 days of PCAP. This is for you to have 1 PCAP per day of what's going on in the network, okay? Everybody? Questions? Internet? No questions? OK, so once you run that, let's be sure that tcpdump is running, because we don't want to miss it. So you now have to get out of your tmax with Control-B-D. So now we are free to type again. And once that you are out, we are going to list the processes, PSAFX, if you remember from last class, and we are going to grab everything that says tcpdump. Only show me the lines that says tcpdump. And this should include the tcpdump that you just executed, OK? So everybody can see the tcpdump running? Internet? Do you see the tcpdump running? If not, you did something incorrectly, and you should go and fix it. And you should have a file, because at the end of the class, we are going to analyze this file. So please be sure that you have it, OK? I will give you some seconds to make this correctly. From questions to come from the internet. Ready? OK. The next step is that from time to time, please go to your Docker and copy the PCAP out, because we usually found Dockers running PCAP for a long time, and then they're using, I don't know, 200 gigabytes of disk space, which is probably too much. So please don't do that. After today, or maybe a couple of days, just go copy the PCAP out and stop the tcpdump, OK? If not, we are going to be forced to stop it for you. And these are the commands you can use to copy them to your computer. So SCP is the SSH copy. You should provide the port that you are using In this case, in the Stratos CyberLab is 2222. The port is with capital P, notice, not small p like in SSH. And then your user in Stratos CyberLab is localhost, and then everything pick up in your TMP and whatever folder you want to store it. And the same for you in the Dockers of CheVeute, okay? So, now that you have everything running, we are ready to actually start doing the class on security. So the first step of our penetration methodology is the reconnaissance part. How do we find out what's out there regarding this that we need to analyze? In real life, if you remember, we do much more. In real life, when you are doing a pen test, somebody gives you a domain, and then you go to the internet, Facebook, TikTok, Instagram, LinkedIn, who is working there, names, emails, domain, registrations. We don't do that here because we don't have that information. But at some moment in time, you end up with a set of IPs, a range of IPs that you want to scan. You want to see which computers are there, okay? So this is the first process of finding out information. And in this case, we are going to start with the range, and then we are going to be doing which IPs, port, and services are there. This is so you know what to attack, okay? What's there, which computers are there. And some companies want to give you the list of computers. You don't want that, because you don't want to use the computers they believe they have. You want to find your own computers, because they usually don't know all the computers they have up, okay? So every time you go there, you have to scan the whole range to see which computers are up. There are usually two types of network security reconnaissance steps. One is passive and one is active. In the passive one, you just go to a computer and you try to find new IP addresses without sending packets. And that means sniffing like you're doing now. Maybe even if we go, okay, we'll see later in the PCAP, you will see some IP addresses in the network, computers that are talking to each other. That's good for you. Now you know that there are other computers out there. You can even go to the files in the computer and list which other computers are there, like etc hosts or stuff like that. That's completely valid. In the active one, we actually send packets out trying to get responses from the computers, okay? So, and the tool we are going to be using is called Nmap. Anyone uses or knows Nmap? Yes, yes, on the internet. Yes, yes. So this is probably one of the oldest and most used, recognized, and beloved tools of network security. Nmap is crazy complex, crazy big. It can do many things, including attacking, brute forcing, many things. So Portscan is kind of a 5% of what Nmap can do, okay? You can go and check it later. So first question, how do you know that the computer is active, is up? Is working? How do you know that? You may try to ping. So ping, you send some ICMP echo request. How do you know that it's active? It responds, and it responds with? What is the answer coming back to you? The reply, exactly. So you send echo request and you receive echo reply, and then you know. Which other technique? How do you know? Sniffing the packets is good. And active ones, other active ones, apart from ICMP? Let me ask again, which are the generic conditions that you need to know for order to realize that a computer is up? What do you really need? Forget packet types. What do you need? You need an answer, right? Any answer. So you don't care if it's ICMP, if the packet says get out of here, whatever. Actually, you don't care. Any packet getting out of that computer to you, it's enough to realize that the computer is acting and up, okay? So what we are going to be doing is trying to force these types of answers back from the computer, and there are many ways, okay? So any packet, I don't care. Maybe I'm expecting an ICMP echo reply, and you get an UDP, whatever. Actually, I don't care. Whatever you get, you have it. Yeah. So we are going to be using Nmap for this, and Nmap works much better if you actually use it as root. Many more techniques. In Strato Cyberlab and in Dockers, you are root, so you're fine. If you are doing this in your computers, run it with sudo or something, okay? So let's start. If you're in the Strato Cyberlab, please be sure that you go to the class number 2 here, class number 2, and that you start the Dockers there, okay? In the Strato Cyberlab, please start the Dockers in the class number 2, because now you have the information that you need to do the class, okay? We are going to start with multicast and broadcast sniffing. So this is a passive technique. Nmap can do passive. It's very good at this. So we are going to be running Nmap, do not resolve DNS, be verbose level 1, and we are going to just set -- script discovery. This is because Nmap, a long time ago, put into Nmap the ability to have modules or scripts. And these are created in the Lua language, which is very simple. So you can extend, I mean you, me, everybody can extend Nmap with any technique that you want, only by creating a very small Lua language program. So you create a Lua saying, I want to check this new protocol. If I receive an A, then send a B. And if I receive a C, do that, exploit, whatever. And then you publish, and they can incorporate it. And then the people can choose from these scripts. What we are doing here is actually choosing the scripts that are marked in the category discovery. And we are going to say Nmap, just run them, okay? So I'm going to run this in my Docker. Probably this is too small font for you. That's better? Background people? People in the back? Better font? Super. If you do that, it's going to say Nmap version 7.8, loaded 307 scripts for scanning, script pre-scanning, initiating the Nmap script engine, that's the NSE, and now it's running. Actually can use showdown, but we don't have an API. It can do many other things that we don't have an API, so let's gonna wait for that. When you are actually working with Nmap, and Nmap is running, you can press certain keys and modify the behavior in real time. In particular, any key will show you the status, and if you put V is augmenting, the small v is augmenting the verbosity, capital V is decreasing the verbosity, V is augmenting the debugging level, capital D decrease the debugging level. So here, you should have this in your computer saying, hey, look at this. I actually found something. The scripts said that the broadcast PIM discovery found these computers. These are other people in the network. And they're actually there, and you can do whatever you want. This is other computers right now, and you didn't send any packet. You were just listening for this type of information, and they were broadcasting something. Okay? Clear? Questions? There have been no questions so far. I'm a little bit afraid of this. Sure, no questions. Okay, there you go. So now that you try the multicast broadcasting and sniffing, and while I'm talking, I'm going to be running this in the Strato Lab. Oh, wow, that was much faster. Oh, no, I actually copied the other one. This one. I need to copy this. There you go. Yeah, it also works there. I wanted to tell you that in the passive category, there are many things that are going behind the scene, many protocols. A lot of them you don't see here because you don't have, I don't know, a Chromecast connected. But if you have, you will see it here. So after the passive, let's jump into the active. And the simplest, fastest technique to find computers in a local network is the ARP technique. And for doing the ARP technique, we just need to say to Nmap, hey Nmap, look, -SN. -SN means ping scan in the old terminology. Not ping anymore, but it's ping scan. Which means disable the port scanning. Do not port scan, Nmap, please. Just find computers. Also called the discovery, okay? Discovery of host. So we are going to say, do not port scan, do not resolve DNS, go to our network 172.20.0/26. We're going to be talking later what is this notation. And then just try to find computers there with IRP. So I'm going to go to my Docker. I'm going to press enter. And I found computers. Did it work for you, everybody? Yes? How many computers did you find? I cannot hear that. 63. 63 because, well, there are many Dockers for all the students here, so you found more of the computers. If I do this in the Strato CyberLab, it's going to say, well, you only found 3 computers up, right? So before telling you how this is working and what's going behind the scenes, I want to explain what is this notation here. Do you know the CIDR notation, this /26 or 24 or something? Anyone who can tell me what is this notation of / something? Yes, go. Perfect. Did you get that? I'm going to repeat. The first 26 bits are the address of the network, and the rest, up to 32 bits, is the address of the host. Do you agree with Damian? No. Huh? Dan. So do you agree with Dan or not? They're not very convinced, or they don't know. Yes, do agree. No, you don't. You don't know. No? Yes, somebody there agrees. Very, 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 very nice. Thank you very much. So, if you remember, in IPv4, we have 32 bits for the whole IP. And I think I have a very nice image here. By the way, CIDR is the classless interdomain routing created in 1993. And it's very funny because in 1993, they created this specific addressing to solve the issue that they were running out of IPv4 addresses in 1993, right? And they, yeah, let's solve it. So let's create this one. Actually worked pretty well. So this is how it works. You have an IP address, and you are saying after the / how many bits you want to use to reference what is the network. In this case, you're saying 24 of these bits, that's all of these ones, the blue ones, the violet ones, and the orange ones, are going to identify the network. And after that, the remaining 8 are going to be used for the hosts in that network. That means the first host in this network is the .1, and the last one is .254, because you have 8 bits. And I'm missing something, right? How many numbers can you get for if you have 8 bits? Well, you also have the 0, right? So the 0 here is a special one. That's why we don't count. It's kind of the address of the network. The host can take from 1 up, okay? Another example with /26. Now you have 2 more of these bits that are used to identify the networks. That means that you have actually more bits for networks, more networks, and less bits for hosts. That means less hosts. In here, you can only go from .1 to .62. And that means that in a network /26, you only have 62 hosts. Okay, everybody? Important when you are scanning, because you should not scan outside your range. So pay attention when you're putting the CIDR there. Okay? So, I wanted to say that how do you know what's going on behind the scenes in this scan? Okay, so let's take a look. And I'm going to actually take this piece of information that is saying --packet-trace, and I'm going to add it to the previous command. So you're going to have to make it. So if you add packet trace to Nmap, it's going to show you kind of in a tcpdump way the packets sent in the network. So if you scroll up after it finishes, scroll up, you will see the packets. And there is where you confirm, oh yeah, it was sending ARP who has this IP, tell my IP. And then you have replies coming from, okay? Confirmation of the technique by ARP. Now, if you want to jump out of ARP, and by the way, ARP is awesome because if you're in a local network, you should answer this. It's not good in the internet. Do you know why? Somebody can tell me why this technique is not good for internet hosts? The ARP technique? Internet? I mean, the people watching us from the internet, do you know why the ARP technique does not work on the internet? Come on, play with me. Because it works on second layer, it's a good answer. I will go with yes. It's working in data link, kind of fish, internet-ish, in the middle of those layers. That means that it's below the IP layer, which means that you can do this without even going into the IP layers and routing and the rest. And also because this is meant for that layer, the data link, specifically for the protocol Ethernet, which means the Ethernet type of networking. When you go to the internet, that's not Ethernet in the rest of the world. You go out of your Ethernet connection and you go through, I don't know, satellite connections or Starlink connections, and they have their own protocols. So there is no concept of ARP in those other type of protocols and networks. So your local network has Ethernet and ARP, then you don't know. And then there is another local network at the end that they have their own ARP, but you don't care because it's completely out. Okay, everybody? So let's say now to Nmap, okay, I don't want ARP. Let's send the rest of the techniques you have. So this is the command we have here. Nmap sn -n, the network, send IP means always send an IP layer. That means do not do only ARP, send IP layer, and packet trace. So let's gonna do this and see what we see. And I'm adding also pipeless, so I'm putting all this information in the less paginator so you can see page by page what's happening. Okay, everybody? Internet? Run this. You should see what's going on. I'm also gonna press -S to chop the long lines. So I'm gonna do wrapping of the lines. -S, enter inside less. So, what can you tell me? Which techniques are being used by Nmap here? What do you see? ICMP. Which type of packet? Which one? Request, yes. Is it sending replies? It's receiving replies, not sending. You can send replies, by the way. But it's sending requests. This is the ping technique, and then receiving replies. What else? You can go down. You can go down and see others. You can actually scroll down by pages. I'm pressing F, but you can do whatever. For example, there, I have other technique. Who can tell me what is the other technique? Internet? Do you have delay on the internet too? Okay. Do you know how much? No. YouTube. So, which technique? Yeah, go. TCP sync. So here we have a packet saying, hey, you are sending to the computer 01 to the port, which port? 443, right? The port is after the colons. A packet with a SYN, so you're trying to connect to a port. And if you go down, scroll down, I'm pressing F, but you can do scroll down. You have others. What is the other? Huh? Acknowledge, very well. So we have 172.20.02, that's me, sending a packet to the 00, that's weird, that's a network. Port 80, but it's not sending a SYN, it's sending an ACK, which is weird. It's like, wait, what? Like, okay, whatever, Nmap. But that's on purpose, and that's because if you establish a connection, you send a SYN, and then you receive a SYN ACK, and the SYN send an ACK. And then after that, all the packets may have ACK or they have push. So Nmap here is trying to tell this computer and the firewall behind this computer, hey, actually I belong to an established connection. I'm sending an ACK because this connection was already closed in the past. I mean, sorry, open. I am just merely sending data in a connection. And if the firewall is a good firewall, you say, no, you don't, because I have the register of connections and you don't belong to an established connection. So this is a little bit of trying to see how the ports answers to this ACK, and the correct one should be a reset. If not, it means that, hey, maybe a firewall is in front of these ones, or actually the port is closed. So this is a technique trying to force an answer back, okay? So what else? We have another one. Which others? Packets, 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 packets. Packets, packets, packets. Which other technique do you see there? Look, it's in front of you. Yes. Timestamp request, that's another one. And this is actually an ICMP, remember, Internet Control Message Protocol, that one of the messages, this is not ping anymore. This is, I want to know your timestamp. And hey, if you answer, then I have it. So if you go down, you will see these techniques repeated and repeated and repeated to find the computers. And those are the techniques that we put in here. Okay? So new techniques to find which computers are up. So next one, UDP. In UDP, we are going to try to find computers, but actually trying to get an answer from a UDP. So if you run this, you're going to see some things, and actually have 62 host tabs, one less. So there is a host that is not answering UDP. What do you want to see from UDP? So UDP is very close to port scanning, so I'm going to talk about UDP port scanning, which is the technique used here a little bit later, okay? But with UDP, you can send packets and also get responses back. The packet you are sending, if you do the packet trace, if the packets are sending are something like this, and is fixing the destination port to 40,125. So actually, you can even detect this if you have an intrusion detection system, okay? And some of the values in the TTL, the ID, and the IP length are, not the IP length, these two are randomized. So actually, you don't have any idea the information about these ones, okay? The answer you are trying to find with UDP is when the port is actually closed. When the port is closed, you will find this type of answer. Because if you remember, UDP does not have a state. There is no UDP port close packet. There is a packet using which protocol? ICMP. So ICMP is used to say, hey, port unreachable. This is the third type of ICMP that we see. Okay? Everybody? Yes? Okay. Now we have ICMP ones. That means that we can specifically send packets using different types of ICMP. And we have the first one is echo request. This is the same as doing a ping. So I'm going to put it in here. Oh, wait. I need to reset my terminal because I lost it. There you go. This one, PE, is going to send ICMP. As you can see, not all the computers are answering ICMP. We have only 39. Then we have another one that is the other netmaster request, the same one that we saw before. That is the PM technique. And this one is going to find less and less because it's a very weird thing to have open. Please try it. And the last one is going to be the timestamp query. There is a type of ICMP that is called timestamp, and it's asking for the timestamp of the remote computer. We don't care about the timestamp, we just care about the answer. So in here you have 3 computers up answering this. Okay, everybody? We found computers. Now you have your computers in the network, and now you know how to find them. So there are other methods that we are not gonna do here, like PA, that is a specific type of ACK, and others. But the majority of these ones do work and very well. Okay? So, questions before we stop the host discovery? Now we are able to go here, or to the internet and find hosts and which ones are up or down for you to scan. The first part of your penetration testing. Question, is it illegal or unethical to Portscan? Especially now that we have 1,500 people online and you are going to be doing this from your home. Is it illegal or unethical to do port scans? And maybe we can do slash on the internet? What do you think, people? It depends. That's a nice answer. It depends on what, Lucas? Very good. If you have a friend that is a lawyer, usually pays off. If it's a good lawyer, yeah. So this is a very hard topic, and there is no clear answer, okay? Especially for the people in the internet. While you're here in the university, you are covered because you're in the university, and you have our authorization, and it's our infrastructure, so everything is fine. And also, everybody knows what you're doing here. In the internet, I have no idea, people. You are in some country, maybe you are in a very weird, faraway country like Argentina, so I don't know, you should check your laws. But I would say this, that in general, for the whole world, talking about all the countries, I would say probably it's not illegal. But in most countries of the world, it's not illegal to perform scans from the countries. So if you are in some country, and if you are sitting in the country, scanning another country, the source country, they don't care so much. It's like, yeah, whatever. This is not important. What is illegal in some countries is that if you scan them, so it's not illegal to scan them, they don't care if you scan from them, if you know what I mean. So an easy protection would be, well, never scan the country where you are sitting right now. That's very bad. Actually, never scan the same network that you are sitting right now. That's also very bad. Like your ISP, very easy to take you down. Your university, very easy to take you down. So never do that, okay? Some countries may still not allow to scan from them. I don't know, depends on the law. But I would say that if you're in clear, don't scan without permission, right? So usually try to have permission for this. This is like the high level one. However, is it true that as security practitioners, as students, as researchers, it's very common to scan internet hosts? Like, yes, that this is done almost every microsecond. So if you're aware of the risks, if you avoid doing it from your home computer, and if you know that you're ethically doing this for security benefits, in general, I would say that it's okay. This is very controversial, and probably some people don't like it, but imagine that you have companies on the internet, Google, that are scanning the internet completely, the whole time, non-stop. And nobody's complaining to them because they are doing it for the benefit of humanity and they are having a company. So maybe you like it, maybe you don't, but in general, you are fine if you follow these rules. However, be aware that port scans can actually disrupt hosts and networks. It's very common people that go into some organization, then run one Nmap, full timing, full packet, and then the networks just die because they're not ready for this. Especially small devices, IoT devices, power plants, nuclear plants, they don't like it. So be careful when you are doing that there. So you're going to be scanning this range. This is our range, belongs to us, so you have authorization to do that, okay? That is a public-facing internet. Internet people, this is our range. You have authorization to do that, okay? Everybody, questions about this before we jump? No questions? Any lawyer in the room? Good. So, now, password time! This is a password time for the secret password of this class for the internet online people. So I'm going to do it without a lot of further ado. The password is handkerchief. Handkerchief. And yes, there is a typo. We are so smart, right? Handkerchief. I'm going to stop saying that one. If you are watching online, go and put this password on the password form. I didn't put the link there, but it's on top. So let's jump into our next one, that is interact with servers. How do we interact with server? ports. What is a port? A port is a software mechanism implemented in the transport layer, TCP and UDP, to actually allow you to send and receive information from the application to the rest of the world. So ports, yes, like boats ports, are meant for this, okay? So I'm going to give a fast premiere of why and how ports are considered open or not, okay? So TCP, if you send a SYN packet and the port is open, you receive a SYNAC. If the port is closed, you receive a reset or reset-ACK. If the port is filtered by a firewall, what do you receive back? Question for you. Huh? Nothing? What do you say there? Denied? Which is the... The question is, you are sending a SYN packet to a computer that is protected by a firewall that is filtering everything. What do you receive back? This is your normal traditional firewall. Let's say no fancy weird things that nobody likes. The 99.999% of the firewalls of the internet. Nothing, because that's the purpose of the firewall, right? In old times, in the 60s, some computers were sending back administrative prohibit port. Why? Why you are doing it? You're using bandwidth. Don't do that. So that's what happened in TCP. In UDP, I'm sending a UDP packet. What do you receive back when the port is open? Internet? Maybe you have time? You don't care. That's true. But now I want to know if the port is open. So I send a packet. What should I expect to receive back if the port is open? Nothing, because the protocol says nothing should go back. So the port is open. I receive the packet. Thank you very much. I don't need to answer you. Nothing go back. If there is a firewall blocking and filtering and discarding the package, what should go back? You know this one, I'm sure. You're just shy. I'm giving you time to get the courage. Nothing. Thank you very much. There you go. So, because you have a firewall. So the problem we have is that, hey, if the port is open or filtered, we cannot distinguish the states. And that's why Nmap sometimes put open / which ports were open, did a list, and say which are the ports that are more probably open. They did the whole list. They incorporate into Nmap. And now those top 100 are the top open ports according to our probability. Okay? So you should have here the ports open in that range using the SYN scan. The SYN scan is the default, most common, faster method that you can use, okay? And if you can see here, still scanning others, and if you press, it's saying, yeah, everything is done, but I'm still waiting for responses, so it's gonna be some time like that. Especially because all of us and all the people on the internet are scanning the same computers, so the computer gets a little bit slower, okay? So, questions about this port scanning? Open ports? No? Yes? I have no idea. Yes, thank you very much, Mari. How often is the port of most probably ports on Nmap updated? No idea. And I would say my guess would be never. But maybe we can ask Fyodor. Or we can check the code too. Okay, so if you don't do that, if you don't put the $F, you just do the, let's call the vanilla traditional Nmap, Nmap, SS, and then just the range of IPs. Oh, here we have the answer. So look at this. Nmap scan report for this IP. The host is up. This is the latency. Not showing 98 closed ports. 2 ports are open, Telnet and HTTP. By the way, how does Nmap know that Telnet and HTTP are the protocols? Huh? Banner grabbing. Banner grabbing means getting to the port, waiting for some data to come back, that is the banner, welcome to my web page, and I say, your web page, right? It's a good answer, but it's not happening here because we didn't get any banner yet. Because of the definition, that's correct. If you go to RFCs, the internet said, in which port should we deploy telnet? Let's put 23. And there is a list of ports and numbers. So actually, Nmap here has no idea if that really is telnet. It's just saying, that's port 23, that it's assigned to telnet. I didn't check, go check, okay? The same with SSH and others. So we have HTTP, HTTP13, HTTPS alternative, we have Black Ice Ice Cap, we have OWL, that is filter, look at that one. Other filters here, AFP, Kalogin, SSH, and others, okay? Now we have hosts and we have computers. If I do the same command without -F, it's gonna scan the top 1,000 ports, which is a little bit more, okay? So it's gonna take a little bit more time. Do you see the problem here? Like some techniques, small amount of port, faster. More ports, it's gonna take longer. Up to you what you want to find, okay? If you want in particular to scan one port, you can actually ask for -P and put the port like 80. And I'm going to also introduce in here the --open. I will put it here later. But the --open means only show me the open ports. So you don't have all the problem of, oh, this is filter, this is closed, this is filter closed, filter closed. So here you go. You are only scanning the 80s and only printing the computers, 197, 200, 205, that have open ports, okay? Questions? No? Perfect. Then, if you want to scan all the ports, you just said -P, you don't put an initial port, usually you do from port 10 to port 20. If you don't put an initial one, and if you don't put a final one, that means -P-, you scan all the ports. How many are all the ports? Do you agree with Lucas? 65,536? So that or 2 million? No, 65,536. You need to be precise. Do you agree or don't? This is a very straightforward number that you should know, right? 2 to the power of, and it's 16. Sorry, I'm going to repeat for the video. It's correct, and it's the number includes the port 0. Usually people say 65,535. That's not correct. Port 0 not only exists, you can actually open it, and some malware do. So does. Now, other types of port scanning. We already did this one. You send the SYN, receive a reset ACK, and that's it. The port is open. You can try the SA ACK scan. We talk about this one. I send an ACK. If you receive a reset, the port is closed. Some of these techniques cannot differentiate all the states, okay? TCP connect. You do this when you don't have root access because you cannot be magical. I forgot to say that in the SYN scan, I send the SYN, I receive a SYN ACK, and I never close the connection with the ACK. That is the new thing, because it's not closing, it does not appear in the net stats, so nobody finds this very easily. But I don't need to close the connection with an ACK, because actually the SYN ACK is enough to know that the port is open, okay? Then we have very old ones, just for the record, SN, the null one, no bits, SX for Christmas scan, you just light up the flags like Christmas lights. The SF, the fin scan, they just don't work anymore. And then you have for SCTP protocol. Okay, everybody? TCP port scanning? Yes? You're going to be doing this one. So remember, you need to try. So let's jump to UDP. UDP is slow, very, very slow. Why UDP is slow? Because it's stupid protocol? No. What is slow? UDP. You're not stupid. Very nice, Lukash. So you send a packet. The protocol says, if it's open, I don't have to answer you. So how do you know? And how do you know that ICMP port closed and reachable is going back? You have to wait. And waits takes time. So smart, right? So you're there, and then it's not coming. Should I wait? I don't know. Should I leave? Okay, next port. But maybe the network was slow. So UDP and Nmap is actually managing the timing, how much to wait or not, and you will see that it's taking longer. You can get it faster with the T parameter. We will see this in a while. But usually that means if you speed up Nmap, you're going to lose ports, okay? So to do Nmap for UDP ports, you can use SU. I'm going to be doing it from here. You just can stop the previous Nmaps with Ctrl-C. There you go. And it's telling, hey, all of these ones are closed. No open ports, okay? UDP is a very tricky protocol to find because it's there, it's open, it's working, and it's very hard to find. So actually, if you want to hide something, maybe UDP is a good protocol. So now that we have the services, now that we have the ports, we need to find out what's running in those ports. Which computer, not so computer, which program is actually there listening, okay? So how do we do that? Who has some ideas? How do you find out which application is listening in that port? Internet? I know you have a delay, or we have a delay, but if you can answer too. How do you know, people? Come on, play with me. No, how does Nmap know that this port with the number 80 has HTTP or actually has SSH or has whatever, right? There is no rule. You can put any protocol in any port. So how do you know? We have some thinking there. Very well, that was correct. So, like, wait for me. Robert. How is your name? Yeah, I should go with Jan. That is 80% probability, right? It's like, I should play the odds very, very much here. So as Jan was saying, yes, you start talking protocols with the port, and then you will see there is no other way, right? You start with the port you expect, but then that's it. So Nmap is doing this with the SV, fine version. So you can run the normal Portscan, and then you can run SV, and then you say, hey, that computer in particular, that it's in your networks, and then you say F, fast ports, and PN, sorry, that's an old one, PN, should be SN, but yeah. In the old times, it was PN. And that's it. It's saying, oh, wow, look, now the port 22 is open, the service is really SSH, and now you have the banner that here will say, hey, check the banner. And the banner says, OpenSSH 8.9 P1 Ubuntu 3 Ubuntu 0.10 Ubuntu Linux Protocol 2.0, okay? And actually have operating system and others. So that's much better. Now Nmap is talking to this port and finding out exactly the version, okay? So let's do another one. Let's do this one in the internet computer. So this is gonna be also for all the ports, and all the ports find the version, okay? So if you do that, it's gonna find a lot of ports, 445, 443, 80, 139, 5000, 548. Do you remember 445? No? NetBIOS, Windows, file sharing protocol, together with 139. Okay, it's gonna find what's going on. Please run this. Is it working for you? Are you trying? Yes? No? You can also play with that. Put more port, less port. Oh, there you go. So we have, hey, the 80 is running Nginx. The 139, the NetBIOS SSL is running Samba, SMD 3.4 in the workgroup, actually called workgroup. Then another Nginx in 4.4.3. Then the Samba, another Samba, that is the Linux implementation of NetBIOS in 4.4.5. Then the Netatalk in 5.4.8. And another web page, Nginx, in 5000. And actually, Nmap was smart enough to find which type of device it is. Did you see it? Nmap was saying, oh yeah, not only you have these ports open, I know this type of answers. And they belong to a Synology, is saying here. So this Nmap is already trained to find the type of device in here. So you can actually start building all the map of which computers, which ports, which services, and everything. Okay. Then we are going to be running some scripts. Remember the Lua scripts I was saying before? You can do this with SC. If you just say SC, you're going to run the default scripts. I'm going to be running this while I talk to you. But as you did before, you can actually pick scripts one by one, or you can pick groups, okay? The default ones are usually not aggressive, not invading ones. So these are the, let's say, good services, good scripts. So here it found the port 548 and the net attack, and actually Nmap has a script specifically for this protocol and found a lot of flags, like some hexadecimal flags, super client is true. I have no idea what is this. UID true, U2F8 server name, open directory, reconnect, server notifications, machine type, UAM, server signature, and others and others and others, okay? So that actually was very good, and Nmap was able to find everything. And you can find all the Nmap scripts and check what they're doing there, okay? And you can search categories with this. And with this, you can put one by one, okay? So now, let's do another thing, because Nmap is awesome, but actually the best way to find out, not the best one, but a very good one, is do it yourself. Go and do it yourself. Sometimes Nmap is like, I have no idea what is running there. Well, you have to go and check. And like we did in the first class, this is done by NCAT. So NCAT, some IP, and some port. So if you do that, you're going to find actually you can talk to these ones and you can do things. So let's gonna do this first one here. If you are online, internet, do this command to this IP address. And if you are in person, do this one inside, because inside you have access to the mail server of the CBUT University, which is maxfeldi CBUT and you're going to connect to port 25. If you are on the internet, you don't have access to this because it's not in our hands, but we found some open SMTP relay on the internet, so you can actually go and connect to this real internet host, okay? So what are we going to do? We are going to connect with NCAT, and we are going to talk to this protocol. And this protocol, that is the protocol SMTP, port 25, let me do this one here. 25 is SMTP, Simple Mail Transfer Protocol. It's a protocol to transfer simple mails. So we are going to be sending mails, like real mails, by hand. What? So let's try this one. You have to type a little bit fast because the SMTP servers are expecting computers and not humans. So if you are slow typing, they'll say, yeah, you're out, bye-bye. They don't want spammers, right? So let's gonna try to send an email to some person by hand. So I'm gonna actually copy paste these lines one by one, okay? So first connect, and it's saying, oh, SMTP server's ready. Then I'm gonna do the first line, which is hello. Hello is coming from extended hello. And I'm going to say, where I'm coming from? I'm coming from sasasasa.com. Oh, nice to meet you. These are all the options you have, like pipelining, size, and yeah, see, I already timed out. I will do it again. So it's like, yeah, pipelining, size, you can start TLS and others, okay? So the first thing you do is actually say, hello. Hello, this is where I'm coming from, .com. And then you can say where the mail is coming from. In this case, mail from info@fel.cbut.cz. In the CBUT email, you need to come from any real account in the CBUT system. If you're online, you don't need this. So that means that you need to know, usually it's your source email address, but as you can see here, you are not forced to put your real source email address. You can put any source email address. Okay? So, ethical concern here, people. Please do not abuse it, okay? We are learning. You can do this on the internet. Now, please don't abuse it here because the university will have something to say about it. But we are going to test, and we are going to send from info@fel. So let me do this all over again because the timeout. After the mail, maybe I can do it here, right? After the mail, you have to say RCPT to, recipient to, where are you sending to? And we are going to be sending to rigakmar@fel.cbut.cz. Do we know some? Rigakmar, Riga, Maria, Rigaki? No? She's not here. So, so Mari, you're going to be the lucky recipients of 1,400 emails. And then, I hope you're ready. And then once you are put in the destination, you need to say data enter. And from this data enter on, we have a little bit more time because we can put the subject and the text of the email, and then you just do all you want. And when you want to send the email, you do dot enter, and that means send the email, okay? So let's try again, and let's try to send an email to Mari. Please do the same on the internet with the other computer I told you, okay? You have the same commands. Mail from, that's okay. The recipient is gonna be Mari, that's okay. And then data, and now we are a little bit safer. And we are gonna put the subject, is gonna be, this is really me. And then, sure, sure, is me. Give me something, okay? And then when you want to send the email, you press dot, enter, and that's it. Bye-bye, done, okay? So please try. I want you to experience talking with the protocol by hand. Computers, we don't need them. And go and send some email. If you are doing this on the internet, you should have the same experience. I would just do the first one for you. There you go. And you should do exactly the same on the internet, okay? That's the internet. When I'm coming from, actually, we don't need here, so it can be coming from test. And then I'm going to go to Mari, and on data, and subject is going to say, hoi, you, is going to say, and then I will send it, okay? So please try. You can send emails to your friends, saying, hi friends, how are you? I really, really miss you. Be sure that you try, people. This is a moment. You are here with us. Errors are fine. You need to experience this in cybersecurity. Attackers are doing this. You should test your systems. You should know what's possible and not possible. You should know how fast it is. I will give you some time here. Mari here promised to answer each one of you. Automated reply. Do you have a sorry, I'm on holiday automatic reply? Sorry, I'm being DDoS. I will answer you later. Okay? You're good? Did you send emails? I have the impression that this may not be real. Okay? More time you need or not? You're good? Did you try? Yes? Okay, super. Let's continue then. This was the idea of how to connect to these ports and actually try to send and do things online. The same you can do, for example, with POP3, which is port 110. You can read emails. POP is to read, not to send, to read. So if you go there, you authenticate, then you can read emails, okay? The same you can do, by the way, with Gmail. But that's it. So, yes, if you know the protocol like MySQL, you can use your own clients, MySQL client and other clients, up to you, okay? So let's go into a little bit of what else can Nmap do. Some of this we are going to be doing, some of this we are not going to be doing. The first one is timing. Timing is crucial. Nmap has like 10 variables of what to do faster and slower to have a better result, like the amount of retries, the amount of delay or timeout between expecting the packet back and sending again, and things like that. However, there is a huge parameter called capital T that you can set from 0 to 5, 0 being paranoid, and then sneaky, polite, normal, aggressive, and insane. The default is 3, which is normal. And this is changing all the parameters of timing to go from a very paranoid 1 packet per hour to insane, which is 100,000 millions per second, okay? So you can actually avoid detection if you are doing this, like being polite or sneaky. So you can try this. Be careful again. The more faster you go, the more you're going to be losing. So maybe you have to repeat the scan several times. Port scans are not deterministic. We are kind of outside the standard of the protocol here. We are doing cybersecurity. We are doing whatever we want, which means do not expect things to work or to be repeatable or deterministic or actually be up when you do a scan again. Okay. Other ideas, Nmap-D, you can put fake IP addresses and Nmap is going to send packets also from those fake IP addresses, which means that you're going to be doing a real scan, but the receiver is also going to receive fake scan from other IPs, whatever you put. So that's actually hiding which is the real IP address of the port scan because you are sending from too many. That's D. Then we have the abuse FTP to relay connections and actually using proxies with Nmap. So you can jump around like in the movies, okay? The last one we are going to be seeing is the fingerprinting of the operating system. I'm going to be doing this in the computer. So it's finding computers, it's finding ports, it's going to be doing some tests, and it's going to end up saying, okay, look, the results are a little bit unreliable because not of everything I wanted was there. The device type is kind of a general purpose computer. It's running Linux 2.6 something, maybe 3. And in particular, these are the Linux kernel, the details of the Linux, and there is an uptime guess. The computer has been running for 154 days and other things, okay? So this is the operating system part of Nmap. Trivia, how does Nmap know the uptime guess? Internet? How does Nmap know the uptime guess? What do you imagine? What would you do if you're Nmap? He asks. Like from the phone, hey, excuse me, can you that's a good one, actually. A little bit slow, but will work. But ask what or how? How? How is asking what's your uptime? Is there an uptime protocol? Uptime port? What was it? Somebody was saying something. What was it? What you were saying? Counter incremental, yes. Which counter? But something is incrementing, that's true. Somebody else? So actually, there is a weird thing that I completely break when I was doing this. That is the TCP timestamp header options. TCP has options inside the header for reasons. One of those options is called the timestamp. So some computers are actually putting this. So you can actually check the timestamp and you see literally the timestamp in the option. And the timestamp is 0 when the computer boots. So by checking the timestamp in the options, if you have those, you can guess how many days went by from the time this computer boot. Okay? Not always work. Okay, and the other one is -A. You can do everything. -A is everything. Do all. UDP, CMP, port scanning, version, operating system, all together. It's kind of like, I don't want to put the options, just do it, okay? And the last one we are going to see is O, which means output. If you do -ON, you actually create a file with all the results, so you don't have to be doing everything, okay? And you have XML and grep formats and other. For you to know, if you want to have, for what is for me the fastest Nmap ever configuration, would be with these parameters: T5, minimum parallelism, max timeout, max retries, max scan 0, min rate. But be careful, you're going to be losing a lot of packets. But that's going to finish very, very, very fast with the majority. Okay? Questions? Or we can jump? Yes. Questions? Internet questions? Hi, welcome. Internet? Questions? Question people? No? Okay. Let's analyze some real pickup file. Now that we're scanning ports, we found computers, we did everything, we are going to jump in, okay, wait, how do we see this in the network? Let's jump a little bit to the defense. How do we actually find out that the port scanning is happening to my computer right now? You are sitting in your computer, how do you know you have been scanned? Well, you don't. and then we want to find out, okay? So for this, we are going to introduce a little bit of packet analysis concepts. So the goal is to know how to analyze the packets and identify whether it is an attack, to know tcpdump and Wireshark. I hope all of you had Wireshark installed. We will be using first a training capture 001.PCAP, which is the same for everybody, so we can go through this one together, and then we're going to be analyzing your own PCAP from the scans, okay? So this file is in this folder /data training capture 001 PCAP, both for you here in Chevauté and you people on the internet in the Strato Cyber Lab. So wherever you are, just access this folder and everything is going to be there, okay? First, we are going to analyze this with tcpdump. Remember tcpdump, the default standard program for actually looking at packets, and we are going to be doing, hey tcpdump, -TTTT, that means print the date time with year, month, date, hours, seconds, milliseconds, microseconds of every packet, the whole timestamp, because we want that. That's the TTTT. -N, do not resolve DNS host names. -S0, capture the full payload. -R, this is new, means open a PCAP file and read this PCAP file. And then we are going to pipe, and we are going to be using something called tcpdump colorize. That is a program from the internet that puts colors into tcpdump. It doesn't matter, you can copy from your Docker if you want later. And then we are going to be using less to do the pages. -R, which means respect the colors, okay? So if you do this command, and if you go to your Docker, or if you go to your Cyber Strato Lab, you should have the tcpdump, okay? Everybody, can you see that? Yes? Perfect. Now we are looking at packets together. That's good. Packets, people, network, finally. A small notice in here that when we are analyzing packets, it's a huge, for me, an incredible technique in cybersecurity, because you are not only looking at what your computer is doing, you are actually looking at what other computers are doing around you, and you can actually see the behaviors in the computer. Somebody's going to Gmail, somebody's downloading something, somebody's chatting in WhatsApp. And if you have a network where the packets go through you, you can see a lot of people attacking you, or you can see all your network actually going to the internet. That means that you can protect thousands of computers from one position in the network. So doing network security, it's a perfect point to understand what's being done, the behavior of computers, the behavior of malware, and to protect many computers simultaneously, okay? It's not only to see pickups and that's it. So we are looking at packets. First column, the year, the month, and the date. Second column, it's the time, hour, and then seconds, and then microseconds. Then we have the protocol, ARP, IP6, and others. And then we have an interpretation. In this case, ARP requests who has 10.02.16, tell the computer 0000. So first, what about 9070.01.01? Is it correct? Do we have a capture from the 70s? Are we hallucinating? Do we have a bug? Did we back in time? Are we in the matrix? Who are we? Where are we coming from? Okay, maybe not that one. But, so what do you say? 1970, January the 1st. Unix time, thank you very much. The born day, hour, second of Unix in the time. That means that if you are counting in Unix time, you are counting in seconds, and the seconds start in 00000000, which means that when we see this, it means that that packet in the pickup, the time actually is 000000. When it's interpreted, that means January the 1st, 1970 at 0009, okay? That means that this capture was capture in a way that it's not real, the date there. Whoever did this capture, whenever this capture started, it was filled with zeros the first packet, and then going up. So it's not broken, it means it's kind of a, let's say, special type of capture virtualized. So then, who can tell me what is the IP address 0000? Who said who has 10.02.16? Who is 0000? Who is talking? Who is talking? Oh, there. The default gateway says Ivan. Vlad. Vlad? I'm very lost here. I will go with Vlad. So default gateway, do you agree? You disagree? And better, oh, there, yeah, agree or disagree? Disagree, why you disagree? A what address? A valid. It's 000 a valid address? Yes, it is. And 000 is, so a better question is, what is a default gateway? Sorry. Huh? Somebody was talking there. I hear you. Okay. So it's valid. And what is a default gateway? So a default gateway is IP address in your network. Okay, are you ready? Follow me. You need to send something to the internet. That means outside your network. So when you go there and you want to follow and fill the 4 values that you need in every packet, source IP, source MAC, destination IP, and destination MAC, you need to put those. The destination MAC, usually you find with ARP, remember? But now you want to send to www.google.com. www.google.com is not in your network. There is no MAC address for www.google.com. So what do you put in there? You put in there the MAC address of the computer that is responsible to take you out of the network. That computer, usually your router, is the one that when you put the MAC address there, even though the IP is the IP of Google, 8888, for example, you put the MAC address of the local computer in your network that is responsible to take you out. That we call the default gateway, usually your router. So here is saying, hey, I think that's your default gateway. It's not, but thank you for the answer. Somebody else? What is 0000? So 0000 is the no address. Literally means, who is telling this? Somebody that does not have an address yet. I don't have an IP address. And actually, that's the reason why I'm asking. That packet means, hey, I want to put myself an IP address. Actually, I want 10.02.16. Before putting my IP address, I need to check that nobody has it. So this is like, hey, I want to avoid collisions. Who has this IP address? I still don't have an IP address. So that's the meaning of this packet, okay? The second one is IP6, which means it's being sent by the source address, colons, colons. In IPv6, that means 00000, colon 00000, colon 0000. In IPv6, you reduce all the zeros and you delete them for simplicity. That is the same concept as 0000. It means I still don't have an IP address, but I'm sending this to this destination IPv6 address. That is a multicast group, a local link multicast group. That is not an IPv6 on the internet, it's local. And you're asking exactly the same question. Hey, who has that IP address? I want to actually put myself the IP address FE86D blah, 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 and I need to know if somebody has it or not. Then another IPv6 asking for the ICMP router solicitation. I want a router. Then IPv6 asking for the multicast listening report group. Then another IPv6 asking for another multicast listener report. And if you check actually the IP address, the IPv6 one, is the IPv6 address that was requested before. Then we have another IRP now asking for who has the 10.022. That is the default router. And is now coming from the 10.0.2.16 because finally the computer assigned itself an IP address. Then we have a replay, the router is alive. Then we have a solicitation of DHCP information, DNS servers, and other information. Then we have some repetitions, 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 some multicast going to the port multicast DNS 5355, asking for information, another UDP, but now in IPv4, multicast, DNS, some time exceeded transit, another repetition, and that's it. So from this packet up, that is a computer that is booting up, people. This happens in particular in Windows when you turn on a computer, a lot of these packets go out trying to find information. When you see this, you should say, oh, a computer is booting up. It's a new computer. This is not a computer that was there before. Okay? Questions? Yes, you don't know from here, but yes. Well, yes. What was the question? Yes, sorry, thank you. If it was a Windows computer, I say it was, but for those packets I highlight, you don't have that information. You would have a little bit later. I'm going to go back to the document. Okay? Okay, I'm going to jump the time zone issues unless you have time zone issues, because the packets are captured in specific moment and place in time. You can do this to fix it. So now let's try to actually see the content of packets. The content of packets is done with capital -A, and capital -A is going to open the packets and show you what's inside. This is the inside. Right? And the inside in this case, well, we cannot read it because it's binary and it's not for humans, but those are the ASCII representations of everything that is happening inside ARP. Now we have this for the IP6 and others. From time to time you have some ASCII by mistakes, by chance, but that's it. In this one, we have for the first time in the DHCP solicit some information about the name the computer wants for itself, that is Win1. So it can be anything, but we have an indication that this may be related to Windows. Then there is nothing, nothing, nothing. Another important packet is this one. If you remember the multicast port 5355, 5355 is the port for multicast DNS. And in this one in particular, we are asking for the WPAD. WPAD, it's the Windows Proxy Auto Discovery Protocol. That means that when we turn on your Windows, Windows goes to the network and says, do we have a proxy to go to the internet? Can somebody tell me about this proxy? That's that packet. So if your network administrator has a proxy for everybody, it's going to answer and say, yes, I'm your proxy. Of course, an attacker can be in your network saying, sure, 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 I am your proxy. Just send me all the packets. And this is a very valid and still recent attack that works. If you go to a Windows network, you start the proxy auto discovery proxy, and then you are going to receive all the packets from all the computers, which is bad, by the way. Okay, so this is how you look at content of packets, okay? If you have questions, you can tell me. I'm going to scroll down to this packet here. This is the first packet after the booting up, where the computer, 10.02.16, in some source port that we don't care, asks the computer 8888. Who is 8888? Google. Port 53, which protocol we usually have in port 53? UDP. DNS. And some values. It's asking for the type of register A, which is IPv4 address. And it's asking for www.msftncd.com. What about this? Do you know it? Is it domain? Is it good? Is it bad? Is it infected? Are we attacking? What's going on here? What's that? So that domain, MSFT, comes from Microsoft and is the network, so this sensor indicator, I forgot the name, but it's a specific way for Windows computers to check if they have internet. You know, when in Windows you used to have this, you don't have internet, or you have it icon. That's what it's doing. It's trying to go to the internet. And yes, the domain exists and belongs to Microsoft. So yes, every time Windows boots up all over the world, all of them connect to Microsoft and they say, hi, I'm here. So they know how many are there. So this is a DNS IPv4. This is the answer. Then you have, again, the repetition, again, the answer with IPs, okay? And then for the first time ever, you are seeing a packet connecting to a port to this IP address that just came out from the DNS, so you know it's this domain, to port 80, and you are sending a SYN packet, which means you want to open a connection. So you open the connection, then you send the SYN ACK. The dot after the S is the ACK flag. So this is a SYN packet, this is a SYN ACK packet, and this is an ACK packet. And the connection is established. Pa-bam. Okay? Questions so far? Okay, let's jump back to tcpdump. Now, you can also get the -- number to have the number of packets. Usually we do this if you want to ask questions. For example, here you can say, hey, packet number 5 or packet number 8. So if you need the packet numbers, you can have them there. And let's do a little bit of analysis, just a little bit more to know what is this capture. The goal of analyzing this capture is to understand it and also to know what's going on in the capture. Is it benign computer? Is it infected computer? Are we seeing an attack? Are we under attack? So let's do a little bit more of this analysis to know what's going on. So after, sorry, I will go down to the previous point I stopped here, since in ACK. After this communication was established, if you scroll down, you will see that actually we are asking for a web page, port 80, HTTP. So you can see here the client doing a get method to /ncsi.txt, that's a file, HTTP protocol, the same you did last class with your fingers, connection close, user agent Microsoft NCSI, network indicator, I forgot again, I'm trying to remember. And then you have the host name, and that's it. And if you scroll more down, please check that you have this. You will see the answer from the web page saying 200 OK, everything is fine. The content length is 14 bytes. This is a real date. Finally, we know the real date, not the packet one, the real date. We have it from here. Connection close, content type text plain, and then some cache control. And this is the actual content, the famous 14 bytes that says is sending back. Microsoft NCSI. Okay? That means you have internet. So far, nothing here is telling me that if this is infected or not, right? I have no information about that. But if you scroll down a little bit more, you will see that the connection is closed, FINAC, ACK, and then you go back more, you have more RAPs, again, more DHCP solicit. There is a repetition because it's like trying to find still information. So this is repetitions, and then we have this one here. This one, it's again a DNS request to port 53 to get the IP address of timetweetout.com. And we will see later in Wireshark, but this one, nothing I can say, nothing there telling me that this is infected or not. It's just some domain that is being asked, okay? Clear so far? Analysis of packets, how to look, what to look. Now, let's open a little bit. Oh yeah, we have some filters here. So, for example, I will do some filters for you. At the end of tcpdump, you can do things like UDP, and you press enter, and you only see UDP packets, okay? If I actually do UDP, but I don't show the content of the packets, so you see more, you can actually see all the UDP packets, see? All the UDP. And this is nice because if you remember, we were looking at timetweetout.com, and you will see that we are asking for this, getting an answer, asking for this, getting an answer, asking for this, getting an answer, asking for this. This is like too weird, right? That this is a moment where we say, wait, what's going on? Normal computers only ask once, maybe twice. You don't ask 20 times. So this is telling you that it's a weird behavior going on in the network. As this UDP filter, you can do others, like UDP and port 53, host 80 and UDP and others, okay? Questions so far? TCP, packets, behavior, connections. Okay, so let's take the time for a break. We have the second break, and we have 10 minutes, okay? So 28 is now, 38, we are back. Yeah, okay, let's continue, people. You ready? So, two things. The first one is, if there is something that you don't get, ask questions. I know I sound repetitive, but I know there is people here not asking questions. So please do, if not to me, to the people here, don't be shy. We are here for you to learn. So this is your moment. Don't let it go. The moment for learning is now. You have the right, go ask questions. Like, I cannot connect. I have no idea what's a Docker, what you're talking for. Chatting matrix, right? It's fine. You don't have to know. And the second thing I'm going to say is that people were asking me, hey, can we attack each other? For sure. The CTU Docker network is for that. So you have assignments. You have other people's Docker. We don't care. You can want to go and connect and get into the computers of others. That's up to you. That's not an issue. We just ask you, please, not to take down the infrastructure of the class. The rest, whatever. Maybe the real question is, can you attack others? You don't have to wait for us. There's going to be more assignments on this, but it's up to you, okay? We have many stories of people doing many weird things to each other. So let's continue them. Regarding the tcpdump analysis, we are going to jump to Wireshark. So please open your Wireshark. And in your Wireshark, I'm going to open my first class, this training capture 001, and I'm going to make this much. What about that one? Is now? Can you see that? Better? Back people? Yes? Back room? No? Can you read that? People in the back? Yes? Thank you. So Wireshark, the visual GUI of packet analysis, also probably one of the default standards for analyzing. Very fast. In tcpdump, you can analyze many more packets, 100,000 packets very easily. You can go high level to things. Awesome. Wireshark, I use it more for going deep, for understanding specific packets, specific connections, specific data that was being sent. But if you have a lot of information, 100 gigabytes or more, Wireshark is a little bit weird. So some questions are easier to answer with tcpdump, some questions are easier to answer with Wireshark, okay? So in Wireshark, we have a first column with the packet number. The second column is the time, but actually I'm gonna check to the exact same time that you have. That is this. The date, and everything. Then there is the source IP address here, you can see. Then you have the source port. I think that you don't have the source port by default, right? I'm correct? I think you don't. I don't remember this. And then destination IP here. And then you have destination port, or the destination port you don't have. I don't remember. Can somebody tell me? Do you have both ports? No. Okay, so to put the both ports right now, you do right-click on the name of this column, right-click on any part of this menu, right-click in any part of this menu, and when you right-click, you will have here things that you can choose to put. So be sure that you choose the destination port and source port. If you don't have the destination port or the source port, please tell me, because we can add them. We do or we don't? We don't. Perfect. So let's add them. To add something in here, you have to go to the column preferences. Column preferences, okay? So click column preferences. Sorry, I forgot to put this in the document. We can add it later. And in column preferences, you have here all your columns. You're going to click in plus, okay? And then you have this new thing at the bottom. You double click what says new column and you put here the name you want, like the port or something like that. Then you click where it says number and you choose destination port and resolve. Destination port and resolve, okay? Destination port and resolve. Oh, sorry. Then you click destination port and resolve. And now you can choose in which position in your columns is going to appear. So you can actually drag and drop this and say, oh, I'm going to put you, I don't know, after the protocol or something like that. Okay? Let me do that again. Okay, you don't want to go there, whatever. Oh, there. And then you click OK. And that's it. You should have now a D port column with the destination port. Did it work? Yes? If not, ask for help. We have Maurice there, watching like a hawk. Okay? Perfect. Now I will delete mine because I have many destination ports. Where are you? Here. You can do the same with the source port if you want, not super necessary. Then we have the protocol, right? ICMP6, another, the length of the packet, and I'm going to delete my column host because I'm going to tell you about this one later. And then you have info. Info is kind of the interpretation, okay? So here we see the same that we did before in tcpdump, but much nicer in colors and interpretations. Also, when you click on a packet, I'm clicking now in packet number 2, you have two windows at the bottom. The bottom left is for each specific layer of the protocol. So you actually can open this and learn about the protocols. Oh, this is a sender MAC address. This is a sender IP. This is the opcode, stuff like that. And to the right, you actually have the raw data, exactly the data that goes into the network. And if you click on the protocol, you will see that it's changing and telling you what is what. Perfect for learning protocols. That's awesome. So yes, now you can spend all your time learning about protocols and header. Right? Yeah, you are welcome. So you can now go through these packets one by one and do the same analysis we did before in tcpdump. So let's try to do something here. Yes, you start, what is Wireshark, the 3 main panels, the packet list, we saw that, configure columns, yes, 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 we already have some columns. So the first thing we are going to be doing is menu statistics protocol hierarchy. So if you go on top, you have here statistics. Is it zoom enough? And then statistics, you have protocol hierarchy. And in protocol hierarchy, you will see all the description of all the protocols, what's Ethernet, what's IPv6, what's IPv4, how many packets, the percentage, and things like that, okay? So if you're looking at that information, all the hierarchy of protocols, what is calling your attention there? What's I don't want to say anomalous, but kind of interesting. There is something there that you should say, huh, I should probably check that. Look carefully. Looking is half of solving the problem. Malform is good, right? So it's like, why malform? What happened in there, right? What else? So these ones, you kind of know what's going on. Oh, UDP, Real-Time Transport Control Protocol. Local link, this is DNS. What about data? Data means, well, I have no idea. It's like, this is DNS. Well, this is nothing. It's literally data being transferred. I have no idea. So this should tell you, well, there is an unrecognized protocol here, we should go and check. The same with TCP, okay? And actually, a lot of those, 17% of the packages are data, okay? So that's protocol hierarchy. Then we have menu statistics conversations, again, statistics, conversations. And in conversations, that's a very, very useful way of looking at the packets because you can have in the top conversations in the IP level. That means IP to IP. And now we have an IP address talking with this one and the amount of packets. So look at this. Very fast, you can sort by amount of packets and have the two IPs that talk the most in amount of packets. Oh, then you know, okay, that IP I should check because something happened there, okay? And also the same with amount of bytes. You can search for amount of bytes and say that is the connection that actually send the most amount of bytes. Then you can do in, well, IPv6, and in TCP level. When you do it in TCP level, you now have the ports, which means that it's not IP to IP, but it's IP port. And again, you can search and find the connections that have the majority of the packets, the majority of the bytes. And that's a very nice analysis of knowing who talked to who, how do they talk, which ports they were talking to. And look at this one. Like the IP address is on the internet, 168 something, and what is the destination port? Can you tell me? What is the destination port? Come on, play with me. You can say something even if you don't know if it's correct. So you have here source IP, source port, destination IP, destination port. So it's 8,529. Do you know which protocol it is? I don't, which means who knows? So we need to go and check and then find out what's going on in there, okay? So let's continue a little bit more. Find a TCP packet and let's try to find all the information that was sent in that connection. When I'm saying a connection here, I'm a little bit losing the definition, but I will call a connection everything that is coming from the same source IP, same source port, same destination IP, same destination port, and same protocol. Every packet showing the same 5 values, Wireshark is getting them together in one connection. That's why you have something here called a connection, and you have many packets in there. Okay? Was it clear? Internet? Was it clear? So, find a TCP packet. I'm going to close this, and somebody tell me the packet number of some TCP packet, so I can go there. I'm just going to... 162. 162. There you go. This is a TCP packet. We know because it says protocol TCP. So I want to know what happened inside this connection. What something sent, received, I have no idea. And for that, standing on the packet, you do right-click, and then you do follow, and then you do follow TCP stream. Okay? Right-click on the packet. You can do UDP too, it doesn't matter, but follow TCP stream. When you do that, you would have a window like this, and in this window, you actually would have in red all the bytes. So let me show you here. In red, all the bytes sent by the client. In blue, all the bytes sent by the server. Okay? So let's do a small analysis of this. It's what type of protocol are we talking here on top of TCP? HTTP. Ah, he was faster. HTTP. And which method are we using? Post. I'm not going to go now in the difference between get and post. We are going to go that later, but there are not many differences between get and post. In here, the post usually means I want to send something. Not always, but let's say that for now. I want to post information. Where is this information being posted to? So you have the folder /forum view topic.php. So it's trying to access a PHP application using protocol HTTP 1.0. We're talking about the 70s here, so that's weird. And then the host is timetoitout.com. Okay, whatever. It's accepting any type of page, the encoding, the language, the content is 179. The content type is application octet stream. What does it mean, application octet stream? It's telling me I'm sending you something, and the format of this something is an application octet stream. It means kind of a binary thing. There is no ASCII, nothing that's recognized. I'm just going to send you a bunch of bits, and that's it. That's the meaning. And then the connection close after, the encoding is binary. This is the user agent, which means the browser used to do this connection. And literally, those red things in here, those are the bits being sent. Okay? So do you know what is that? I have no idea what is that. That means that there is no real easy way to recognize what this is being sent as part of the post. But I would say that first, if you are posting to a view topic forum, and if you are using HTTP 1.0, and if you are sending an octet stream of bits that I cannot recognize, all of this is very suspicious. Like, this is not your typical behavior in an HTTP application, okay? So there are signs that are going to tell you, yeah, I should probably check this. Is it malicious? Maybe, I don't know, maybe not, maybe yes. But for sure, this is not what you expect in your typical HTTP application. And then the answer is not found. So it's not there. And then some web page actually I will go with the error page saying there is an error, you didn't have it, okay? So, there you go. This is the content of the TCP. Clear for everybody? This session, right? Those are the packets of this connection. Okay? Clear, everybody? No? Yes? Maybe. On top, there is a place where you can actually write your filters. The filters are very similar to TCP, like UDP, TCP, ICMP, HTTP. In particular, after doing the following, Wireshark automatically put the filter TCP stream 7. That is the 7th stream or connection. So if you want to go and see back the whole package, you can delete this or press X here, and then you're going to delete the filter and you see all the packets again. Okay, everybody? So let's continue. Filters. TCP. Let's do this one. You go here, put TCP, you press enter. You only see TCP. If you pay attention, to the right, there is the interpretation of these packets. And in this interpretation, you can see, for example, that again is asking the view topic, and again is not found this connection. Again is sending the view topic post. Again is not found. So there is a lot of repetition. Repetition is not a good idea. Like if you go to a web page and the web page is not there, what do you do? Huh? You don't go there. No. The first thing you do, refresh, F5, boom, refresh, right? It's like internet is down or something. But exactly like, how's your name? Teresa said, after you refresh, you don't go there again. It's like, it's not there. So why this program is going to be topic 20,000 times? That's a little bit unusual, okay? We will see a little bit more about this later. Okay, so you can also filter by IP addresses, or you can filter by protocols or IP addresses. One nice one is that you can do HTTP, which actually recognizes the port. So it's not port 80 or 443, it's everything HTTP. And you can now see all the times that it's asking for post forum, post forum, post forum, post forum, and others. Okay, so I'm going to stop in there, and I want you to tell me what you see that is suspicious or clearly maybe malicious even. There is something there that you say, wait, what? Executables, there you go. So after all these post forums, and if you pay attention, after the post forum that receive an OK. So not found, not found, not found, not found, not found, cling, the page went up, you have an answer. This answer did something, you should go and check inside the content, and then actually try to download an X file. Was it successful? Well, it's 200 OK, so I will go with yes, it was successful. Actually download a binary file for Windows. Then try to download something more, but it was forbidden. Something more was found, and then an index, and OK, another one forbidden. So this is evidence that some X file was downloaded. And that's confirmation that most probably this computer was infected because it was doing multiple connections to the post B forum and then was downloading X files that actually succeed, okay? So far we can now conclude that that computer was actually infected by something. And we will learn later that these files is actually in the PCAP, so actually you can extract the X file. Just be careful because it's real malware, okay? So you will have some issues if you are especially using Windows. You have been advised. So one of the things that you can do when you do HTTP is the time of the packets. So I don't like this view of the timing, so what we will do is view time display format seconds since the previous display packet. Seconds since the previous display packet, okay? View, time display format, seconds since previous display packet. And that will show this information. This packet has, to the last one, 5 seconds. 049, 5, 040, 5. 1, 1, I can go up more. Okay, there you go. 5, 5, 5, 5. It's too precise. Like actually every 5 seconds is retrying. No human is so good at this. So we can be sure that there is some automation behind this type of request. Okay? Clear for everybody? This was an infected computer. Okay, let's continue a little bit. We will add a host column that I like a lot, that it's a special host column that actually it's gonna show more information about the connection for easy analysis. So let's do right-click on the column names, go to column preferences like you did before, again press the plus, and the name of this column, I usually call it host, but you can call it whatever you want. The type of column is going to be custom, so you should actually find that there is one of these ones that is stay wherever you are. Oh, there you go. And then you press OK, and now we have a column that is called host. The good thing about this column is that now you have the host of HTTP directly there, so you don't have to go and open and follow the stream or anything. It's very easy to see. And if you delete the filter and you go back to DNS filter, enter, actually you will have the query also in this column. So this column is going to fill with the HTTP host or by pipe, the DNS query name, or it's going to be filled with the TLS extension server name. We don't have it here, TLS extension server name, so it's going to be in another capture. But, okay, I will explain it very, very fast, okay? This is called the SNI. The SNI is a field of TLS. Remember TLS? We saw it last class. So in encryption in TLS, it works like this, okay? I'm going to do my best. Hey, computer, I just want to go and get some of your web page. And the computer is like, okay, super, super, super. Tell me where you want to go. Do you want to go to google.com, yahoo.com, and then say, oh, wait, no. I want to encrypt, okay? So I need you to send me your certificate so I can encrypt. And the server is like, okay, sure, but I cannot send you a certificate if you don't tell me to which domain you're going, because I have many certificates for many domains, google.com, yahoo.com, whatever.com. But then, as a client, it's like, wait, I don't want to tell you where I'm going without encrypting, because that's the whole purpose of encryption, to encrypt the data. So I don't want to give you where I'm going without encrypting, just, you know? And the server is like, well, I cannot do nothing. And then the client is, I cannot do nothing. And then no connection, okay? So how did we solve this? SNI. SNI is a special field in the TLS header where before encrypting, let me say that again, before encrypting, we put there the host name where we are going. So the client is, okay, I'm going to google.com. And then the service, awesome, here is the certificate. Now we can encrypt, and we do everything. Which means that the host name of the computer you are going in encrypted ports, HTTPS, it's sent in the open, people. So if you believe that TLS was encrypting the whole of your connection, that was wrong. It's not happening, it's a lie. There is the host name that is never encrypted, which means me, you, the people in your coffee shop, the government, the police, the country where you're going, all of them can see the host name of where you're going, even in encrypted connections. Beautiful, right? So we are trying to solve that for some time. We have something there. I mean, we the community, not me. But this is called the extension server name. And if you have some of those connections here, you will see the host name there, okay? Questions? No? Okay, super. Now, let's analyze a little bit of your scan capture. Remember, we have some of your capture in your TMP data. We started at the beginning of the class. So if you do have this connection there, please use it. I think it was TMP capture something, right? Let me show that again in my computer. You should have in your TMP exactly, right, some captures going on, so you can analyze those. If you do not have the capture because of reason, maybe people on the internet, you can download that from this Google Drive by executing this command. So if you are in the Strato Cyber Lab, you also should have you also should have your TMP capture. Okay, it's there. If for reasons unknown you don't have, you can actually execute this command, the wget, it's going to load the pickup and put in your computer. Okay, so just for you to have something to analyze. So Now, with all the knowledge we have about packet analysis, we are going to jump into the capture and trying to find things, okay? So the first question is going to be, okay, how many packets are in your PCAP capture? So you have a PCAP, people were scanning. How many packets? What are we talking about? 100, 200 packets? And for that, you can run this command, which is a tcpdump, like we did before, only that we are piping it to the wc-l, which is word count lines. Word count lines. I'm going to put in here later what it is. If you execute this command, it's going to tell you that we have 55,000 packets, and that's almost nothing. So this is to give you the idea that there is a lot to look at, right? Probably some of you have more packets than this. You can tell me if you know. So now that we have the amount of packets, let's do the first analysis by hand just to have an idea. This is a practice that also in pen tests we do. We just open the capture and just to see the feeling. What are we talking about here? Is it encrypted, not encrypted, UDP? What's going on? So I'm going to open this with tcpdump, and I'm going to try to see the content. That is like, this is the capture from the Nmap port scanning we did. So it's okay, some IRPs, some IGMPs, some UDPs. Then we have some ICMP call request. Then we have this weird packet that is not recognized by tcpdump that actually is protocol 88D9. And then, okay, I'm going to scroll. This is not deep. I don't want you to see exactly each package, just to have an idea, right? IGMPs, more ARPs. Oh, look, more ARPs. This makes sense because it's an IRP scan. Do you remember IRP scan? Okay, so this is Nmap scanning IRP. I got you. You're asking a lot of computers. Beautiful. Actually, if you pay attention, 60-something, but then starts again. So the scan was repeated many times, maybe 3-4 times, because Nmap is repeating packets. Okay, you're doing that again. Okay, just move forward, move forward. Okay, got you. I'm scrolling, 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 a lot. Oh, okay. You have a feeling how long is a port scan and how many packets you have to analyze, which means that we need some way of filtering this out. You cannot just watch every packet. And now we are in a moment that we have TCP packets, some resets in there. Okay, so it makes sense. After the ARP scan, we actually did a SYN scan, and there are many more things. That's it. Just to have an idea, just to have the feeling of what's going on, okay? So after this, and I will leave you this for later, the specific packets, we want to identify who was the scanner. So who can tell me which is the computer here doing the port scan? Can you identify the IP address of the scanner? Come on, you know this one. It's easy. Which is the IP address of the scanner? Thank you very much, Luca. It's the source IP of the majority of the packets. If you just see all the packets are coming from there, okay? Maybe you have 2 or 3 scanners, but now you identify who's scanning you. This one is easy, right? The computer sending most of the packets, right? So just pay attention, there are more than one. Then, which techniques are used? Okay, so we saw from the beginning, I'm gonna go back to the beginning, and we saw some ARP, IGMP query, some broadcast. Look at the broadcast address, 255, 255, 255, 255. More broadcast. Then actually we have specific port 4070, that is a specific protocol. Then we have ICMP echo request. We have a specific protocol that Nmap is trying to find out. We have more UDPs in specific broadcast addresses. We have, what else? All the ARPs, and then we saw TCP, okay? So looking at the packets, you can actually answer which techniques were used in here, okay? And for a little bit more advanced things, imagine that you have the question, okay, which IPs were scanned using TCP? I want to know all the IP addresses that were the destination of Portscan and how many packets were sent to each, okay? So I'm going to execute the command, and then I will tell you how it works, okay? This is to give an idea that if you're using tcpdump, it's very flexible, and you can do many things on top. And you could do a scripting, and use bash, and this is a one-liner, so you can copy-paste, but you can program this in any language you want. So if you have a good question, you can find this information, okay? So I'm going to execute this command, and this command is going to show that. Tell me if it's also working for you. You should execute this, and you should do list of IP addresses. So this is the list of all the IP addresses that were scanned and how many packets were sent to all of those. We have several IP addresses on the internet, another IP address range in the internet with 2 packets, and that's it. So how does it work? It's going to do a TCP dump. It's going to do the traditional TCP dump to show the packets, but then it's going to filter only the packets coming from the scanner, source host, that one. And then it's only going to show the packets with TCP, because that was part of the question, only TCP packets. Then it's going to be using awk to print the 6th column. So let me show you what does it mean, the 6th column. The 6th column, it's exactly the destination IP. But if you pay attention, it's destination IP, dot port, and then some columns weird thing in there. That's actually very bad. So we want to clean this. The cleaning is the second part, which in awk, we separate columns by the dot, right? Dot, 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 dot. And then we print only the first 4. That's actually the IP address. So far, if you do up to here, you will have IP addresses. And then we do the program sort, which sorts. And then we do the command unique, which print unique lines counting the amount of lines. And that's the whole magic. Then we just sort the list and we show it. And this is showing all the destinations IPs and how many times were packets sent to it. Okay? A little bit advanced. If you don't get something, it's fine. You can ask later. The point is for you to see how this can help you answer questions about the capture. Another one, how many unique IPs were scanned. I will let you execute this one, a very similar command, okay? How many ports were found open and with which IP, exactly the same command. This one is a little bit complex because you are using a specific type of filter that is filtering the flags in TCP. That is flags in TCP. And you want to have packets with the SYN and ACK flags on. SYN and ACK. Which are these packets? Do you remember? Which packets are the TCP that have the SYN and the ACK? Very well, Jan. So when you are searching for ports, you see a SYN. If the port is open, you receive a SYN ACK. That is filtering specific for those packets, SYN-ACKs. And then you can count how many ports were open. There you go, okay? Pay attention to this. Try to understand, because you're going to do it for here, for the assignments, for the exam, for everything, okay? The questions are going to be there. Now, let's jump a little bit into analyzing this with Wireshark, so you have a better feeling of the analysis. So I'm going to open my Wireshark. If you downloaded this capture, like I told you before, you should have it in your computer. Remember the wget command, okay? So even in your local computers, you can do the wget and download that in your computer. Also the internet, okay? So all of you, internet and here, you should see the same exact packets. So the colors are horrible, but the idea is that there is the same amount of information. Look, all the ARP, everything is the same. So where is the amount of packets? Well, this is super easy. In the bottom, Wireshark is putting you 55,300, okay? Amount of packets with Wireshark, much easier. Then you do a first analysis by hand. For example, I have a question. Did they do HTTP? Are they attacking HTTP? Okay, so let's go to the display filter. And let's put here HTTP, and then we press enter. Oh, actually, there was HTTP. So this scanner was actually hitting the ports and was sending things. And if you read, it was sending /nmap lower check something. So this was Nmap, because if you remember, Nmap was connecting to the services and trying to find versions and connections. So if you are defending, if you are in the receiving side of this, you can see and say, that's an Nmap. And actually, that's an Nmap in the vanilla style or the scene style. And you know what to expect. Actually, you may filter this in your firewall very easily, okay? So here you have some HTTP packets. So let's try to see other type of questions. Which is the IP sending the most of the packets? We can do the same we did before from statistics, endpoints, which are all the computers receiving things. And in the IP layer, you can see here, oh, sorry, I have a filter. So I need to go back, delete my filter, and now statistics, endpoints, and you have more. There you go. So in the IP level, all these IPs were connected, so very similar to what we saw before, and even you can search for packets. So which one is the one receiving the most amount of packets? Well, that's the sender, that's the receiver. The first one is the scanner, the second is the one scanned. Okay? Was it clear? No? Yes? Maybe? More maybe than yes? So? Half of that? There you go. Are you sure you don't have questions? I will give you some time. I will give you time for the question to form. Also in the internet. Do you have questions? We should implement something like the class does not continue until one question is done. That's good. Okay, no questions, nothing. Okay. Another way to look at this is which techniques were used, and no real way of doing this automatically, so by hand and filter it. That's the only one. For example, hey, did I send UDP? So you search for UDP. And actually, look, there are not many UDP. There are less than, I don't know, 20 packets. That means that UDP was not used as a technique, which is good to know. Ah, UDP was not here. There is some NetBIOS name service, some very high-level UDP ones to this one. I'm not sure why, actually. And then at the beginning, some broadcast ones, but that's it, right? Another question, to which IP and port were the most number of packets sent? And for that, we can do statistics, conversations, and in conversations, we choose TCP. We did this before, remember? Wait for that. Oh, I have a filter. I can take limit to the display filter off. Let's see. It's coming. There you go. So the question was, to which IP and port were the most number of packets sent? So you click in packet sent here. Again. Wait for it. Take some time. And there you go. It says, okay, to this give a color to this because I like colors. I'm going to give it more something like reddish. I press OK. And then you need to choose it from the right. You need to enable it. OK? And now you have there the moment in times. I'm going to take down the all packets where the scan happened. And you can actually move and zoom in and out and everything, okay? So if you want to know the exact timing, because here you got some weird numbers, you click in time of the day, and now you have the exact timing there. So Wireshark allows you to see these actions in time, behaviors, what happened in the middle. I don't know, maybe the human was actually thinking, and then was thinking after that. So there are like 3 big moments where the scan happened. Do you see this? Are you a graph? Yes? Was clear? No? Maybe? Internet? You should see this at home. So, and yes, we have that. So I will give you some time to check it to finish all the commands. We have 2 or 3 things. I was jumping on some complex commands, so it was not too much. I will give you some time for this. Okay, I will show you a very fast out of the syllabus thing, okay? Just because we have some minutes. So I'm gonna open actually the training capture 1. Remember training capture 1? I'm gonna filter an HTTP. And if you remember, we saw that there was binary files here. And what you can do in Wireshark is file, export objects, HTTP, export HTTP objects, and then you can pick the connections that you want to export, and you have a big one with the X file that is 303 kilobytes, and you can actually export this and save in some place in your computer, and that's a real X file. So this is how you can use Wireshark to get in the connection, get the bytes, reorganize, and recreate the file in your computer, okay? So that is a real file transfer in this capture. And remember, this is a real malware. So be careful, don't double click, please. Maybe just change the extension name so you don't execute it. But that's something that you can analyze later, okay? So in captures, there are files inside sometimes, and you can use Wireshark to extract them. That was extra, was not here, but only for the people watching the video and being here. Okay, questions? No? tcpdump questions? Packet analysis? Executions? Okay, so we are ready to start the ending. We have one extra attack question that now that we have time, I will do it. So the question is, this is an example of a real attack from the internet on a computer. So what can you tell about it that recognize it as an attack? And there are at least 8 things in here that may tell you that this is an attack. So we can do this one. Internet, you can participate too, because we have some minutes. So, yeah, go, Lukasz. Which one again? Which one? Host IP, yes. And that's good or that's bad? I will go. It's an indication that something is going on, right? Because usually what you expect is that I'm connecting to IP, and then I'm asking that IP, right? Because I'm connecting to Google.com and asking Google.com. It's true that should not always happen because you have proxies and other, but I agree that this is an indication that, maybe something is going on here. Yeah, go. Where? Show me. So, this one. Yes, IFS, yes. This one. So, here, wait for me. How was your name again? Dmitry, I knew it. I should have said Dmitry. I was so close. I will count it as I did it correctly. No. So it's saying, hey, there is a weird thing on there, kind of NC. Do you know NC? NCAT, some IP address, and then a port, and then E, and then a shell. Yeah, that doesn't look good. I agree. This is an indicator that something is going on with this capture. Please, that is, hey, actually, you have already a real IP address there and a real port where this was going to go, right? Okay, something more?
They send very suspicious authorization.
Authorization string. Okay, what is authorization string? Credentials. Do you agree with Jan? Actually, yes, right? So we have this basic authentication scheme, no dual factor, whatever. It's just send me your username and password in plain text. That's actually plain text. Well, how do you know what is that? What is that encoding? What is this string? Base64. How do you know that it's base64? There are some equal at the end. So you can have strings with equal at the end and not being base64, but if you have one or two equals at the end, most probably some base64. What is base64? Very well. It's some way of encoding text so you can send it over some networks, right? Is encryption? It's not encryption. There is no key. There is no secret. Base64 is a very well-known protocol. You can go online and decode it. We are doing this because we want to send some binary characters, like special letters of special that has some special symbols, and the only way to send that is to convert them to binary representation. But you cannot send those not ASCII things in the internet, so we transform them into an only very visual, mostly ASCII, depending on the encoding, representation that is base64. So you can actually decode that and find the user and password. What else? User agent, what is it? What is it? User, oh yeah. Exactly. Exactly. If this is a normal human, you have the browser, Chrome, version, Firefox, whatever. You can put a tool, Nmap is put in Nmap, but API tool looks like automated. I have no idea what is API tool. I need to search for this online, ask ChatGPT, but API tool, yeah, this is also calling the suspiciousness. What else? Timestamp. What is it? Show me, show me. This one? Or which one? Nothing good happens after 2 a.m. How I Met Your Mother. Yeah, probably that's enough to say that this is malicious, right? After 2 a.m., got you. So I would say that no, because like first we don't have the year, month, and so I don't know. And 3 a.m. 51 can be whatever. And I don't know the time zone, so this can be actually 3 p.m. So, but good one. The first one we received, nothing good happens after 2 a.m. Go. What else? Caching, caching, caching. Caching control 0 is a good one. It's not malicious, but it's like, do not remember this. So, okay, you can find it there, but I will give you some anomaly points in there. It's a good point. For post is not uncommon. Maybe we can search how often the cache is being used in posts. Yeah, okay, and it has authorization. Yeah. For me, it's still weird, but you're right that maybe posts have some rules on this one. Okay, what else? Port number. What is a port number? 22. 22 is usually SSH. So what are you doing sending to an SSH port a clear HTTP one? That's bad one, right? That's bad one. So there are many. If you scroll in the document, you will find some of these ones there, and you can see other ones around. This one is in particular nice because it will tell you which type of device it is. It's actually an IoT device, and actually this is a real attack. If you do this in a vulnerable IoT device, you will be able to execute commands. So this is a real thing, okay? Okay, so let's stop here. We have a lot of things. We are actually surprisingly with a lot of time. So we are going to assignments. We doing?
Right. So well, this was last. Maybe. Thank you. So first to mention something, and I will also add it later to the document and maybe put into the announcements channel. For the first 4 or 5 assignments, because somebody asked last time, I think, there will be a deadline which is 7th of November to finish them in the CTFD. So the deadline is not immediate, like the day when the assignment is released, but for the we will let you know later if it's 4 or 5, but at least first 4 assignments will have the deadline on the November 7th. Okay, so just an FYI, so if you're not doing them immediately, so you know. Okay, so last week was easy. I think most of you solved the assignment. Nobody had any issues. I think if you have, you can chat us always on Matrix. So this week we actually start with proper assignments and the fun ones. So this week it's kind of a two-parter because we did the service scanning, but we also did this network analysis. So we'll have these 2 parts. And the first part is you will get an IP range. You will see it in the CTFD tonight when the challenge is open. And you will have to scan for some services, and one service will give you a flag that you will have to put in the CTFD. And in addition to that, there will also be 2 questions in connection to that scanning. They will not be like theoretical, but based on what you scan, you will be asked some stuff. And those questions will have a limit on the number of attempts you can try. That's for us to stop the brute forcing of the correct answers. But the number of the attempts will be sufficient for you to like solve it correctly. Don't worry. It's not like if you get it wrong once, you lose a point. So yes, this first part is 4 points. It opens tonight at 9 p.m., just like the last one. And the second part, we will need you to, at 9, start capturing traffic with tcpdump for at least 1 hour. We will be sending some packets, and then you will have to analyze that like we did in the class today. And there, in the packet analysis, you will find a flag in some packets. You will have to do some filtering and stuff. But basically, the commands that we did today, I think there's nothing too special about it. But just leave the tcpdump for long enough so you capture all the packets. So that's why we say for at least 1 hour. Yes, did I say everything? I think I did. So are there any questions in relation to the assignments for tonight? And yes, the Pioneer prizes are also going to be...
We have Pioneer prizes for both or one?
No. It's like, this will be like 4 challenges, let's say. So 2 require flags and 2 questions. And the first one to solve everything like gets the first place. So you might not be first in like the first question, but the first one to catch them all, to use the Pokemon analogy, gets the Pioneer prize, and also like 2nd and 3rd place. So don't give up if you're not first. There's still some prizes.
2 parts, but only 1 set of prizes? What's going on in here? We need to complain about this one.
Yeah, maybe we'll figure something out. I mean, we had a surprise this week,
so who knows
what happens next week. Yeah.
So something else I want to say for the internet people is that also for you, this week we have a new challenge deployed into the Strato Cyber Lab, and you can try also the students. So go to the Cyber Strato Lab, git pull, download the new ones, recreate the Dockers, and you will see a new challenge related to this class. And you can also play that one with the CTF in the Strato Cyber Lab, okay? So you can also have fun online. And this reminds me that if you want to create a new challenge, a CTF for the Strato Cyber Lab, you can do that. It's very easy. You just create 2-3 files and try at home. And if you have a nice idea, and then you just do a pull request and we will evaluate it, okay? So that's also possible. And the last thing is the feedback. Please take a moment to tell us how it was. Also online and here, tell us what was good or not or wrong or fast so we can keep improving, okay? And I think that's it. People, something more? We're ready, guys? Yes? Okay, so thank you very much. We say hi to Ondra and Veronica online. Thank you for being there.
No, just for the assignments, you all, the people here in CTU, you have your private channels. If you get stuck and you really need help, do not despair. Please ask for hints and we'll try to help you move on, right? Because some of the challenges, as he said, have limited amount of tries. So if something you think you doesn't work, maybe it's something on our end, like something doesn't work. So ask questions, don't be afraid.
Yes, yes, it will be written in the CTFD, like, I think it's 5 attempts for these questions. It will be, you will scan something, you will see, and there will be questions, okay, what is something, and then, and you will see, like, if you have a failed attempt, okay, you've used 1 out of 5 attempts.
So see you people, enjoy, have a nice weekend, happy hacking, prepare for tonight, 9 p.m. opens. Get sharp, get stickers for free. Yes.